Japan recently finished building a $12 billion coastal wall. It stretches for 400 kilometers and stands taller than a 4-story building. But to understand how it actually works, you have to look past the massive concrete face, because the most vital engineering keeping the structure alive is entirely hidden underground. On March 11, 2011, a massive rupture displaced 500 kilometers of ocean floor. What arrived on the coast 30 minutes later was a 40-meter-high moving wall of black water that simply rolled over everything in its path. In a single hour, 90% of Japan's existing heavily armored seawalls failed completely. Entire coastal towns were flattened, and the defenses meant to protect them were ripped apart. When engineers surveyed the ruins, they found something unexpected. The world's largest breakwaters and concrete barriers didn't shatter from the brute force impact of the arriving ocean hitting them head-on. This cross-section shows what actually destroyed them. The ocean topped the crest and eroded the soil on the landward side. But the real kill blow came when millions of tons of water pulled back out to sea. This retreating backwash created a massive vacuum, sucking the foundational sand right out from underneath the walls until they collapsed under their own weight. The wall's survival depends on a foundation that stays anchored, while millions of tons of water attempt to vacuum the earth out from beneath it. That meant starting construction 25 meters below sea level, right in the middle of the active surf zone. Because the water was far too turbulent for human divers to see, construction crews had to guide massive foundation stones completely blind, relying entirely on sonar pings to track their progress in the dark. Looking at this foundation cross-section, you can see 5-ton boulders drop directly into the soft ocean mud. Right above them sits a crucial layer, a geotextile membrane. This engineered fabric acts like a filter, preventing the fine internal soil of the wall above from slowly bleeding out through the rocks and into the sea over the next century. To counter the backwash scour, massive interlocking steel sheet piles are driven 10 meters down into the ocean floor, placed specifically to protect the front edge. When the next tsunami recedes, this steel wall physically blocks the ocean from sucking the sand out from under the foundation. With the underwater base locked in, construction moved above the surface to build the wall's internal core. Fleets of dump trucks ran non-stop on 16-hour shifts, hauling in hundreds of thousands of tons of clay to build the primary embankment. This clay has to be perfectly compacted to exactly 98% density. Inspectors rigorously test every single layer, because if the compaction drops to even 85%, the sheer weight of the finished wall will cause it to sink into the ground by a full foot every single day. The entire coastal defense strategy rests on this hidden mass. Long before the first concrete panel is ever poured, the wall's ability to survive a mega tsunami is already decided deep underground by precisely engineered dirt and steel. To protect the seaward face of this embankment, crews stack thousands of heavily armored tetrapods along the coastline. These 32-ton concrete blocks aren't meant to stop the water dead. Instead, they are dropped into chaotic, interlocking piles to create deliberate gaps. When the tsunami hits, water is forced through these narrow spaces, exhausting the kinetic energy of a 50-million-ton wave before it ever touches the main wall. Behind that armor sits the final barrier, thousands of individual 7-ton concrete panels. These are cast in computer-machined molds for a precise fit. If an inspector finds even a microscopic air pocket or surface defect in the concrete, the $800 panel is instantly crushed and discarded. This diagram shows the crown wall sitting at the very top. Notice how the concrete face tilts exactly 10 degrees off vertical. That specific angle ensures that if water does overtop the structure, the kinetic force is redirected outward in an arc back into the ocean, rather than crashing down onto the landward side. A 400-kilometer wall requires the river mouths to be sealed off. To do this, engineers built massive floodgate structures across the waterways, utilizing 50-ton steel doors and concrete frames poured twice as thick as standard walls. When an earthquake strikes offshore, the timeline is dangerously short. These floodgates operate on an autonomous trigger system. The moment a seismic sensor fires, alarms sound, and all 443 coastal gates automatically drop and seal in exactly 70 seconds. The integration of structural weight, precision machining, and seismic triggers creates a system that monitors and reacts to the ocean automatically. The ultimate test of this $12 billion system arrived just 2 years after completion, when a 7.4 magnitude earthquake violently shook the Japanese coast. The response was precise. The seismic sensors fired, the floodgates closed, and post-quake inspections across the full 400 kilometers found 0 cracks and 0 shifted armor blocks. In areas where there is no sandy beach, the engineering becomes even more extreme. High-strength concrete is sprayed at 100 kilometers per hour directly onto steep basalt cliffs, bonding the structure to the rock so that the mountain itself becomes part of the seawall. Warm, reflective tone. Despite being designed for violent forces, the surface reality of the wall today is quiet. The wide, flat crests now serve as elevated coastal promenades, where locals walk dogs, ride bikes, and go for a morning jog. The 400-kilometer wall now stands as a physical defense against the specific forces that leveled this coast in 2011, built on a foundation specifically designed to never move again.